Yeah, good evening, good afternoon, depending on where you are watching from tonight. Uh, we are going to do marathon class. Amen. So we'll be here till anytime when we are tired. That is when we leave this platform. But please do me a favor, like, subscribe, share right now, and comment. I'll be very grateful. Thank you, and you are welcome. It will do you good. Please, if you have any question, don't hesitate to ask. Yeah, follow me. Let's go. Tonight, we'll be looking at some problems. From different universities, polytechnics, college of education, and the rest. We'll be looking at it. We'll be looking at them one after the other in advanced calculus. Okay, here we have a good question. If the z equals to open brackets 2x squared y squared plus 2 sine 2x minus 2xy close bracket dx plus 2x cubed y plus 8y minus x raised to power 3 close bracket dy, show that the z is exact differential equation. It is simple as ABC. Amen. Amen. Okay, so let's look at it together. Please, I want you to copy the question down. It will do you good. Amen. Okay, copy the question down. Okay, yeah, so far so good. At first, let us write solution. Amen. Okay, so if you can see what I am saying, already it is stated that show that the z is exact differential equation. Let's look at it this way. Let us assume that today is your first time of coming across the word exact differential equation. Amen. Okay, so what do I mean by exact? Exact differential equation are equation of the form. If we have equation of this form, m dx plus n dy equals to 0, that satisfies partial m all over partial y equals to partial n all over partial x. Amen. So whenever you come across equations of this form, this is n that satisfy this, it means the given differential equation is exact. Amen. Is that clear? So take notes and be very careful. Amen. Okay, so now we can go ahead to bring the question down. So it means whenever you come across equation, differential equation of this one that satisfies this, note that this is an exact differential equation. Please take it down, please. Are you following? Okay. So now let's look at this question. It means we have the z is equals to open bracket 2x squared y squared plus 2 sine 2x minus 2xy dx, right? Plus open bracket 2x raised to the power of 3y plus 8y minus x dy. Yeah, but I told you that an exact differential equation is of this form. This is M. Please take notes. M, yeah. So it means we have to make the z equals to what? 0. So if we do that, so that it will look like this. So here we are going to have 2x squared y squared plus 2x minus 2xy dx plus 2x cubed y plus 8y minus x cubed dy equals to 0. Can you see now? So you can now see that, you can now agree with me that we have transformed this equation into what? Exact differential equation. True of us. It's true, right? So look at it. This and this, they are almost the same thing. So now, before we can conclude that this is an exact differential equation, it means it must satisfy this condition. Do you agree with me? It must satisfy this condition. It means partial n all over partial y must be equals to partial n all over what? Partial x. Do you agree with me? So we can now let already this, let n, amen, let n be. Is the network okay now? Is it okay now? Please check from your hand. Is the network okay? Please let me know. Check from your hand. Is the network still fluctuating? Yes or no? Please, I would like to know. Okay, is the network okay? Somebody should talk to me. It's okay. So far, so good. I said, as I was saying, I said we have to transform this equation in this form, m dx plus m dy equals to 0, because we must equate it to 0. So if the z equals to 0, look at it here, it is 0. So it is in the form of what? Exact differential equation. Amen? Okay. So if you agree with me, it means, look at it, we have m dx plus m dy. So you don't need a prophet to tell you. You now say, let this m be equals to this. By the time you equate the dx and dx will cancel to give us this. Likewise, equate this to this, dy and dy will cancel. M equals to what is inside the bracket. So now, and I told you that before any differential equation to be exact, it must satisfy this condition. Partial m all over partial y equals to partial m all over what? Partial x. So how are we going to obtain this and this? It is for us to differentiate this partially with respect to y and differentiate this partially with respect to what? X. Do you agree with me? Amen? So let's go. So here will now be partial m all over partial y is equals to, I know some of you are not good at differentiation, but you should listen. Since we are differentiating with respect to what? Y, so we only consider those terms that contains y. Otherwise, it will be 0. We'll just let it be. This one is containing y. Here does not contain y. So whenever we differentiate this will be 0. This one contains y, two of us. So just after this and this. Do you agree with me? Are you following? Any question? Any question? Any question? Hope the network is a bit okay. Okay? So if you agree with me here, let's differentiate it partially with respect to y. So if we differentiate 2x squared y squared, we hold 2x squared, then differentiate y squared, it will give us what? 2y times 2x squared will be 4x squared y, right? Then here there is no x, so here will be 0. Then here we differentiate this 2xy. Since we are differentiating with respect to y, we hold 2x, then differentiate y, it will be 1. 1 times 2x is 2x, but here is minus, so minus 2x. Amen? Then the same thing, and here will now be partial n all over partial x equals, let us differentiate this with respect to x. So it means we are going to differentiate those terms that contain x. Otherwise, it will be 0. We will consider this, we will also consider this. Here will be what? 0, two of us. You don't need a prophet to tell you. So if we differentiate 2x cubed y, we are going to have 6x squared y. Then this will be 0. If we differentiate minus x cubed, we are going to have minus 3x squared. Wow. Yeah. So look at the boards with me. You can now see that partial m all over partial y is equals to this, and partial n all over partial x is equals to this. Two of us is true. So now, come back to this. They said we must show that this must equals to this. That is one of the conditions to make it what? Exact differential equation. Is that clear? So now, look at it here. Look at it here. Look at it here. You can now see that this is 4x squared y minus 2x. Then here is 6x squared y minus 3x squared. So you can now see that this and this are not the same thing. So what we need to do, we now say that partial m all over partial y is not equals to partial n all over partial x. So therefore, it is not exact. Yeah, so look at the board. This is how we are going to do it. So if you have any question, ask so that we move further to consider more examples. Amen. Okay, any question? No question. So it means we can proceed, right? Can we proceed? Okay, there is no question. Let's proceed to consider more examples. So there is no question, right? No question, right? So I can clean the board. Okay. It's okay. Show that y over the x is equals to minus open bracket 2 xy plus exponential y all over x squared plus x exponential y is exact differential equation. Amen? Differential equation. Okay. Yeah, everybody should look at the board. Here we have another question. Very beautiful question here. Show that dy over the x is exact differential equation. It is simple as ABC. Excuse me, in our first example, I made it clear that let us write solution for any differential equation to be exact. It means it must, in this form, m dx plus n dy equals to 0, which satisfies partial m all over partial y equals to partial n all over. Yeah, I can see that the network is fluctuating. Very sorry about that. Network is very bad. It's okay. So let us proceed further. Let's proceed further. The network has been disturbing. It's okay. So let's proceed. Okay. So as I was saying, I said whenever you come across differential equation of this form, if you want to transform it to exact form. You cross multiply. This one multiply dy, and this one multiply the x. Look at it now. Can you see now? So you can now see that we have to take this to the left hand side so that this right answer will be what? 0. So that it will be what? Exact differential equation. True or false? So here we are going to write open bracket x squared plus x exponential y dy. This negative crossing the sign of equality becomes plus open bracket 2xy plus exponential y dx, which is what? Equals to 0. Do you agree with me? Look at the board very well. Do you agree with me? Yeah. Do you agree with me, right? Okay, so if you agree with me, we don't need a prophet to tell you. You just say let this be equals to this and let this be equals to this. So that, so you now write let n equals to x squared plus x exponential y and n be equals to 2xy plus exponential y. So what we need to do here, we have to differentiate this partially with respect to what? Y. So if we can do that, we are going to have partial m all over partial y is equals to, I will only differentiate those terms that contain y. So this is 0. We differentiate this, we are going to have the same thing, x exponential y. Then the same thing applicable, we differentiate this partial n all over partial x with respect to x. This will be 0. Differentiate the terms that contains x. So here we are going to have 2y. So you can now see that this is not equal to this. So we conclude by saying, therefore, our partial m all over partial y is not equal to partial n all over what? Partial x. Therefore, it is not exact differential equation. It's not exact DE. Yeah. Look at the board, look at the board. I want you to look at the board. So this is not exact differential equation. So as you can see, but supposing it's exact differential equation, you go ahead to what? Integrate. So we'll look at 1 like that. We'll look at 1 question like that. So that everything will be alright. Amen. Everything will be alright. Okay, so that is that. Any question, please, before we proceed? Do you have any question that you want to ask? Any question? No question. So it means we can proceed. It's okay. Well, another problem that we'll solve now. So I can clean this. Okay. Yeah. So it says solve. Let's look at it together. Solve solve open bracket x plus y minus 10 dx, right? Then plus open bracket x plus y minus 2 dy equals to what? 0. Amen? So as you can see, how does this equation looks like? Somebody should tell me. This is an exact differential equation, so there is no stress about that. So we write solution, amen. We know that our exact differential equation is m dx plus n dy equals to 0. So this implies that we now let m equals to this and n equals to this. So let m x plus y minus 2. Amen. Somebody should tell us what next to do. Excuse me, look at the board and tell us what next to do. What next? What next? Yeah, we can differentiate this partially with respect to what? Y. So it means partial m all over partial y is equals to, this is 0. Differentiate this 1, this is 0. And the same thing applicable with respect to x. If you differentiate x partially, it's going to give you 1. So you can now see that, and this must satisfy partial n all over partial y equals to partial n all over partial x. So you can now see that this and this are equal. True of us is true, right? So therefore, our partial n all over partial y is equals to partial n all over partial x. Look at it. So we can conclude by saying it is exact differential equation. It is exact differential equation. So since it is an exact differential equation, we have to integrate this exact differential equation. You can remember or recall that ever since we have been solving the exact differential equation, we did not integrate the differential equation. True of us. Why? Because it is not an exact differential equation. But since we have come to satisfy this condition, you can now see that this is equals to this. This is 1, this is 1. So they are all equal. So this differential equation is exact. So it means we have to integrate it to obtain a constant. So whenever, after differentiating partially with respect to the given y and x, if they are all equal, it means you have to integrate the differential equation to obtain a constant. Any question? Please look at the board. Do you have any question? Is there any question that you want to ask? It's okay. So it means we can proceed, right? Okay, let's proceed. So let's go ahead to integrate this function. So here we integrate x plus y, minus 10 dx plus integral x plus y minus 2 dx equals to we integrate 0 to equals to integral 0. Yeah, so far so good. Here you are going to integrate with respect to x. Then here you are going to integrate this, you are going to integrate the values that does not contain x. That is the terms. We discovered that here contains x, so here will be 0. Here does not contain x, you integrate this and this one too. So it means let's first integrate this. So if we integrate this with respect to x, here will be x raised to the power of 1 plus 1 all over 1 plus 1. Then plus, if we integrate this y dx, we are going to have xy. Then integrate minus 10. We are going to have minus 10x. Then integrate this. You are going to only integrate the terms that does not contain what? X. So here is 0. When we integrate this, we are going to have y raised to the power of 1 plus 1 all over 1 plus 1. Integrate minus 2y. We are going to have minus 2y equals to, when you integrate 0, I'm going to give you a constant technique. Either K, any alphabet, or B. Can you see now? Can you see now? So now we are going to have x squared all over 2, because 1 plus 1 is 2, plus xy minus 10x plus y raised to the power of 2 all over 2 minus 2y equals to the constant. This is what they want. Look at the board. Is this difficult? No. Two of us. Remjock Math is always there to make you smile and happy. Anyway, life of mathematics is always beautiful with Mr. OC. Yeah. Okay. That is that. Do you have any question? Please, if you have any question, ask so that we can proceed. Oh, sorry about that. Oh, the name of the equation is exact. We are talking about exact differential equation. Am I? Where are you watching from? Which country are you watching from? Am I? So, do you have any question? Any question? Am I? Which country are you watching from? Oh, Ireland. You are welcome. You are welcome to Remjock Maths. So how is Ireland? How is it all over there? It's fine. You are welcome to my page. Please help me share. We are all here to learn mathematics. Freezing. Oh, wow. Sorry about that. But try and invite me so that I can be your guest one day, if you don't mind. I'll come and teach mathematics in Ireland. So you can invite me, right? Anyway, in case you want me to teach you mathematics, here is my number. Take it down. Plus 234 70 3366 7737. This is my call number and WhatsApp number. You can reach out to me or through Telegram. Anyone. Telegram, WhatsApp, Telegram, WhatsApp, and Facebook, etc. So you can reach out to me, yeah, even on TikTok. Yeah. Any question before we proceed, please? If you have any question, ask. So, Emma, you are welcome. Do you have any question? Is there any question? No question. So we can proceed, right? It's okay. So let's proceed. If there is no question, let us proceed. It's okay. Let's proceed. Let's proceed. Okay. Yeah. We have another question. It says classify the following DE differential equation into type, order, degree, type, order, and degree, and degree, right? Okay, one is q prime prime dot dot plus 2q dot plus 5q and 40 down. The other one is 2, 3, the x all over the t plus raised to power 2 dx all over t square close bracket raised to power 6, amen, plus x equals to 0. Then the other one is 2 y prime raised to power 10 plus y prime raised to the power of 7 plus y prime raised to power 20, then plus y equals to 0. Look at the board. Look at the board. Look at the board. Okay? Then then 4 y prime plus y equals to 6 cos 5t. Yeah, we have a good question here. About 4 questions. 4 questions. As simple as ABC. Everybody should look at the board, please. Look at the board. Look at the board. It will do you good. Look at the board. It's okay. So far, so good. As you can see, they said classify the following differential equation into type, order, and degree. Let's consider this. First one, q dot dot plus 2q dot plus 5q dot 5q equals to sine 40 is alright. Let's look at it together. Yeah, I know very well that those of us that are not familiar with mathematics, most especially differential equations, you may feel that why these dots, and this? You know, yeah, you are always familiar with dy all over dx. So for the fact that this is y, it means this will now be, we can transform, use this notation, y dot, or this is the same thing as y prime. So it means this is a first order derivative. That is what it means. But if it is a second order derivative, it will be d square y all over the x square, which is equals to y dot dot, then the same thing as y prime prime. Amen? Am I? Are you following? Are you following? Am I? Are you following? Okay. So if you are following, let's proceed. Let us proceed. Let us proceed. So now, here we have q prime prime. So it means we can rewrite this in this form. Our q d square q all over the x square. It means this is the same thing as q dot dot equals to Q prime prime. That is what it means. So whenever you come across something of this form, always know that this is a second order derivative. It means it is a second. Why? Because it is what? Squared. But supposing here is cube, we can call it what? A third order. So here, look at this equation, differential equation. We have first, second order, second order, first order, true or false. And we have the constant here. So now, this differential equation, for the fact that what is the highest order in this differential equation is this, true or false. So the order of this differential equation is here. We can call it what? Second order. Second order. Because they said we should classify it into type, order, and degree. That is the answer. Then we say, when we say type is nothing but a differential equation. If we have a differential equation, either second order or third order, if we have a differential equation of this form plus cy equals to f of x, you can now see that this is a second order differential equation, true or false. So you can now see that it is equals to a function, true or false. So this means that this is a non-homogeneous second order differential equation. So the homogeneous DE, differential equation, our f of x is 0. If f of x is equal to 0, you can now see that this differential equation will now be AD squared y all over the x squared plus BDY all over the x plus CY equals to 0. Can you see now? So when you see differential equation of this form, the right answer is 0. It means it is known as a homogeneous differential DE. Homogeneous DE. Can you see the difference now? Are you following? Oh, where are you watching from? Your mom. Turkey, my friend, you are welcome. You are here again. Your mom, how is Turkey? In mathematics, you are welcome to Turkey. You are welcome to Nigeria. Sorry. Yeah, mom. That is what I'm saying. Your name. And I don't know the meaning of your name. Hope you are following the mathematics. This is what I saw. Am I right? This is your name, right? Look at the board. Am I right? Okay, so let's proceed. Let us proceed. My friend, you are welcome. How is Turkey? Okay, let's proceed. It's okay. So now look at it. Look at this idiot. You don't need the prophet to tell you. So me looking at this, this differential equation. Me looking at this differential equation. You can now see that out of this, look at it. You're more. I don't understand your language. Can you interpret it in English? My Turkey friend. Okay, let's proceed. Amen. Yeah. As you can see now, if this is homogeneous, non-homogeneous, then this is homogeneous differential equation. So what will happen to this? Which name can we call this? Look at it together. So we are trying to answer one after the other. It's okay. So look at the board and let's look at it together. Amen. So this one, the type is non-homogeneous. Amen. Non-homogeneous. That's the type of this differential equation. Oh, you are asking of our time. Oh, that is the meaning of what you are writing. Our time is 10:30 p.m. (10:38 p.m.) This is Nigerian time. Yeah. So what is your time over there? Okay, let's learn mathematics. So we have answered this, and remaining this. Then now the degree will now be. You can now see that the highest order here is second order. But when you bracket them like this, if you bracket it like this, you know that there is an invisible one here, there is an invisible one here, two of us. So the power that it carries here, that is the highest order power, that is the order, the degree of the differential equation. So it means here is raised to power what? 1. So we now write degree 1. Degree 1. We have answered this one. So I want you to answer number 2. You have more. I want you to answer number 2. Think you understand English. Hope you understand English. Oh, your own is, that is serious. Here is 10, it's 10:40. Oh, I should wave you bye-bye. It's okay. I'm going to wave you, my friend. Bye. I love you. please make sure you share what you are learning before you go to bed. Is that clear? I love you. Bye-bye. Yeah. Thank you. Yeah, Gmo. Thank you. Thank you. It's okay. Yeah. So let's continue. Those of us that are awake, let's continue to solve, and solve. Tonight is a wonderful one. Okay. Yeah. Let's consider this one. So, if we want to talk about the type of this two, three partial the x all over the t plus d square x all over the t square. This is t square, amen. Then 6 plus x equals to 0. Alright. So far, so good. So, what is the type of this differential equation? Well, let's start with order. What is the order of this differential equation? The order is second order, two of us. Second order, then the type is homogeneous because it's equals to 0. Two of us. Type homogeneous. Amen. Homogeneous. Then the degree of this is what? 6. Degree 6. Degree 6. Why? Because order the power, the highest order of this differential equation of the power, that is the degree. So take note. So this is the answer to this. Any question, please? Do you have any question? Any question? Young man. Chocolate will come when? Turkey. My friend from Turkey. Oh, you are fine, bro. Thank you, thank you, thank you. Thank you for the compliments. I really appreciate. You are also fine too, although I've not seen your face. But chat me up on WhatsApp so that we talk and do video call better. Is that clear, young mom? You chat me up, or you drop your contacts here so that I can chat you up, young mom, so that I'll come and visit you and teach you mathematics. Young mom. Okay. Yeah. So that is 2. So let's consider 3. 3 will be type. Let me just write type or order. Type is what? 3. You don't need a prophet to tell you. Since it is what? Equals to 0. Homogeneous. 2 of us. Then order is third order. Third order. Then degree, degree 10, true or false? Because the highest order of the power, that is what we are looking at, degree 10. Then 4 is type, non-homogeneous, true or false? True or false, because it is equal to a function. So non-homogeneous. Take notes. Then order is first order. First order, DE. And degree is 1. Degree 1. Degree 1. Amen. Yeah, degree 1. So look at the board very well. Look at the board. Look at the board. Yeah, more. Drop your contacts. Let me chat you up. Or you chat me up. Okay. Gentlemen and ladies, thank you for your time and your patience. I wish you all the best. Please don't forget to like, comment, and subscribe. And share. Thank you. I wish you a wonderful bed rest. Bye. Love you guys. I love you guys. Bye-bye.